Hi Challenge B, this is Logic Lesson 22, Truth Trees for Consistency. And first of all, before we start, just tell me, what is consistency? What does that mean for a set of propositions to be consistent? Well, a set of propositions are consistent if they can all be true at the same time. So we've done this before with truth tables, where we assumed that the propositions were consistent, and if we found a contradiction, then we knew that they were inconsistent. So now we're going to learn a new way to test for consistency using truth trees, where we break down a proposition into simple components so that we can look for contradictions. So we're going to decompose a set of propositions into their smallest parts, which are called literals. So we first need to learn three ways that we can decompose just to get us started. So in this lesson, we're only going to learn three decomposition rules, and that's the conjunction, double negation, and the disjunction. And then in the next lesson, lesson 23, we're going to learn a bunch more. But we'll just get comfortable with these for now, and then we will add to it. So first of all, let's look at the conjunction. The rules for decomposing a conjunction is it just decomposes into a P and a Q. And once you decompose a proposition, you want to check it off. Now, a double negation decomposes into just P. And then a disjunction branches. Okay, it branches into P and Q. All right, so we're going to need to remember these as we work through some of the examples and problems in this lesson. But if you've been a little discouraged by logic from the last few lessons that seemed impossibly hard at times, I think you're going to enjoy these truth trees. I think they're fun and they're not as difficult. Okay, so let's look at a few examples. We'll start off with easy ones, and then we'll get to ones that are a little more complicated. So if we're given this proposition here, A, B, or not B, and C. All right, so the way we do this, we put each proposition on its own line. So line 1 would be A, and that was given to us, so we call it a set member. So we label it SM for set member. All right, the second proposition is not B and C, set member. All right, now we don't need to decompose line 1 at all. It's already at its most basic part. So we're just going to look at line 2, and we know that with the conjunction, we just have not B here. And line 4 would be just C. Now we have to label how it is that we came to that. So we were using line 2, conjunction, and decomposition. All right, so that D stands for decomposition. And then C is the same thing. It came from line 2, conjunction, decomposition. And so we see here's an A, here's a not B, and a C. So there are no contradictions there. So we put a circle underneath to say that it's an open branch. All right, it's an open branch. And that means that this proposition is consistent. All right, now when a proposition is consistent, we can write down the truth values. So we have an A, a B, and a C. And we see that A is true, B is not true, so that would be false, and C is true. All right, so there are the truth values. All right, we'll do another example. Let's see here. Let's do an example with a disjunction this time. All right, we're given this set here, F or G, and then not F. All right, so each member gets its own line to start with. So line 1 would be F or G, set member. Line 2 is not F, set member. Okay, so we really just need to decompose line 1, and we know that a disjunction branches into F and G, and that would be line 3. So we used line 1, disjunction, decomposition. Okay, now let's just look here. We have not F and F, so that is a contradiction. So the way we show the contradiction is we say it's line 2 and line 3. So line 2 contradicts line 3. All right, now if we look over at this other branch, we just have not F and G, so there's no contradiction. That's an open branch. And as long as we have at least one open branch, the set is consistent. So this is consistent, and we can write down the truth values. So we have an F and a G. The truth value for F, well, we're looking at this branch here, so not F is false, and G is true. So those are the truth values for that one. All right, and let's do another example. I'll do an example that's from the exercise. We only have 4 problems in the exercise here. Let's see here. Why don't we do number 3. All right, number 3 in the exercise is P, not Q, not P, or not Q. All right, so this one has a little bit more involved with it. So line 1, we're just going to write down our set members is P, set member. Line 2 is not Q, and that is a set member. Line 3 is not P or not Q, set member. So we don't need to decompose lines 1 or line 2, we just need to decompose line 3, and we see that it's a disjunction, and a disjunction branches into not P and not Q, and that was line 3, disjunction, decomposition, and that's line 4. All right, now this first branch here is actually finished, and do you see a contradiction? Yes, line 1 and 4, P and not P, that's a contradiction, so we're going to say 1 contradicts 4. And we can actually decompose this even farther. A double negation would turn into not Q would be Q. So that's line 5, and we justify it. Line 4, double negation, decomposition. All right, now let's look at this branch here. Do you see any contradictions? Oh, we have not Q and Q, so that is a contradiction. So that would be 2 contradicts 5. Line 2 contradicts 5. Okay, so there are no open branches here. So we say that this proposition is inconsistent. Inconsistent. Okay, so hopefully, oops, let me turn this, put that down a little bit. Hopefully you have a little idea what to do. I hope you have fun with it.